This is the second Python code I'm going to demonstrate as part of the first lecture in the mobile source air toxics risk assessment. What we're going to do in the second lecture on Python is to introduce you to very powerful libraries that makes Python at least equivalent to MATLAB. Again, we will start by pressing on the new button. Delete this, we do not need it. And we are going to import libraries. These are Fortran and C libraries that will speed up and give way more power to Python. They're very fast libraries. They are as fast as C, C++, and Fortran. We do this by writing import numpy snp. We will always call the numpy np as a standard, so we will not confuse each other's code with some other name. We will also need to import the plotting library. So we're going to say matplotlib.pyplot splt. Now, as before, let's say that I need to work with vectors or matrices. Python will be a bit slow to do that. So we're going to create variables using NumPy. So we will automatically create a vector here, and I'll say equals np.linspace, and I say 1 to 10, and I want 10 points. So let me write what this means. np.linspace. This actually looks very similar to how MATLAB works. So we'll start where we want to start. We'll start at 1. We want to end at 10, and there will be number of points. And this is a comment. As I described, the code will not read comments. And now we can just say y equals x. I can say print x comma y, and I will do this right now. Click, and I generated this. This is the x and this is the y vector. So I can plot this. I can say plt plot x comma y, and this creates the plot but does not know where to throw the plot. So we have to say show, and we can also say send to a PDF file. Right now we're going always to show on the screen. plt.show, and we're not passing any parameters. Believe it or not, now we can draw. Just click, and you have this XY plot. If I give this plot to somebody, they will know it's a linear relationship, 10, 10, every point will correspond identical to the other one. But I have no title. I do not know what the x-axis represent and what the y-axis represent. So let me close this, and I can improve this by doing plt.xLabel. This will give a name to the x. Let's just call it x. We do the same on the y-axis. Y-label, this will be y. Let's give the title. The name is very easy to remember. plt.title, our first Python plot. We will need to know how to do this because next lecture we'll have things that are more advanced. I need to show you a few more advanced functions, and as you can see here, we have the title, we have the x-axis, and we have the y-axis. We could say whatever it is here, won't matter. Now look at the power of this here. Right now this vector is identical to this one. We did it here. But I could do it the whole vector 2 times. So when we plot, you see the linear relationship, but this is 10 and this is 20. So by doing that, what I did was I multiplied the entire vector without having to loop through each element in that vector. I have 10 elements. I didn't have to go and multiply each one. Could also do something here not so linear. So let's say I'm raising to the power of 2. It will be y equals square x squared. And now the plot is no longer linear. And you can see this is 10, and this is 100. So I will do one last one, and there will be np.ex of x. So this is basic e to the power of x. So this is Neperian e equals 2.7172, etc. And we are basically doing, what we are doing here is saying e raised to the power of x. Is that clear? So I will do this once more. I say this is x cubed. So what I will do is, we have 10 here, and we have 1000 here. You see this plot though does not have enough points, and the plot is fairly jagged. You can see here it has some kinks because we only have 10 points. If I say between 1 and 10 and I have 100 points, you will see the curve is fairly uniform, very smooth throughout. Close this. What I'll do now is I'll still do 100, and now just for you to practice, np.exp of x, and you will see the plot is fairly smooth now. This was very jagged before, and it is very smooth now because I have from 1 to 10 I have way more points. Clear? And this is it for the second segment. I want you to go and investigate how to use NumPy and Matplotlib. Matplotlib we're going to use in every single lecture that we have for the mobile source air toxics risk assessment. Thank you very much.